I'm Johnny, and I'm a principal engineer at Shutterstock, and I'm joined here by my teammate Ben. We run Shutterstock's API enablement team, which is a team focused on stewardship of both our graph and general API delivery practices. In that role, we're focused on onboarding both our services and front ends to GraphQL, and at the same time, empowering teams with continual delivery tooling to rapidly and safely iterate the supergraph and sleep soundly while doing it.
Let's take a small look at what we do at Shutterstock. So we power creativity with more than 1 billion, and yes, with a B, assets of downloaded assets. We have over 1 million contributors and 500 million images on Shutterstock.com only. All of those assets are translated into 21 languages, so that's a lot of data. And all of this data is served through GraphQL. GraphQL really helps us innovate, and since innovation is in our DNA at Shutterstock, we want to move fast, which GraphQL helps us to do. Let's take a look at some innovation that we recently released that are fully powered by GraphQL. So this is our new AI, ethical AI image generator. It's fully powered by GraphQL. So the front end is server-driven UI. It also has, so you can generate, for example, here, dog images. So yeah, so you can change the aspect ratio and stuff. You can also change the style of the image that you want to generate. So for example, you can choose bokeh, so you can have like a more photorealistic image. And then on top of that, we have the extend capability, so you can extend an image, or you can even edit an image. With the magic brush, for example, you can select an area and then just generate on top of the generated image, for example, sunglasses. There you go. All right, and our most recent innovation, I let the video speak for itself. Right, but in order to achieve that speed, we need the right infrastructure in place. And you need to start with your feature 0, the pipeline. I'll let Johnny explain a little bit more about it.
Well, so at Shutterstock, we really are supporting several ways of going about our implementations, and we've found that there's 3 common use cases that we need to support. The first of these use cases is breaking up a monolith. One of our first subgraphs was a non-federated graph. And this is the graph that was used for all of our internal tools. So when customer support cases are being taken, that sort of thing, it's a graph and it supports all of these cases. But we're slowly breaking up this monolith and delegating functionality to domain-based subgraphs. As we do this, leaning on that monolith's existing test suite allows us to be confident we are not breaking functionality. but we need to be able to test against a federated supergraph to do this. Our second main use case that we need to support is full stack teams. One of the goals that often goes alongside a GraphQL journey is moving towards a system where microservices are better aligned to business domains. This often involves the identification of business logic that's leaked forward into the front end and being able to collaborate and move that down into the subgraph domain it belongs. So in the first demo that we had of that AI asset generation, initially we had a backend for front end that was sitting in front of that in order to basically say, okay, you may have the product that allows you to access this, and we've been able to work with that front-end team and the back-end team that built the generation service to move that logic back into the generation service, moving towards a flatter microservice architecture. The third main use case that we need to support is shared entities that drive many features. So we have one creative entity called Creative Image, and it drives things from AI recommendations, generative AI, search, analytics, and just any time an image is displayed on screen. At this point, we have 18 teams that contribute to this entity every week. And so how do we make sure that we can continually iterate this entity quickly and safely without any undetected major breaking changes? The tooling in Apollo Federation for schema changes is one layer of testing, but that just tests the schema. And having confidence for us means that each team needs to be able to run their changes against a version of the supergraph that includes those changes. So dependency on a single important type isn't just a problem we've experienced, it's a design goal of GraphQL Federation. So as your company onboards increasing portions of business-critical functionality to the supergraph, the need to test changes being introduced across subgraphs is going to arise. Entity types, such as our creative image type, introduce the need to test scenarios across the supergraph, and in the spirit of continual delivery, we want to be able to test these changes on every single PR of every single subgraph. So among these use cases, there's probably one anyone in this audience can relate to, and I'd like to pose the question, how painful are your deployments? We've realized the importance of providing tooling that avoids deployment pain, and investing in that tooling contributes to an environment of both mental and technical safety. The point where development meets operations is one we focused on because it allows us to mitigate burnout at the technical level. If developers have all of the tooling that they need to deploy safely, small, and often, we're optimizing for sleep. As Nicole Forsgren and Jez Humble's amazing research in Accelerate has shown, treating the pipeline as feature zero is foundational to effective team performance and sustainable delivery. So, with the reduction of deployment pain as the goal, what parts of this are unique to federated GraphQL, and which parts are just things we should all be doing anyways as engineers? MinimumCD.org is a project that's attempted to pare down the concepts of continual delivery to just 4 pillars, so that teams who may not be familiar with continual delivery can get started quickly. While each of these pillars is important, we'll be focusing on how we addressed having a prod-like test environment in the context of federated GraphQL. So, what's the solution for this? Tests on every commit. And the level of tooling that's required to do that, to break up a monolith, to have multiple subgraphs contributing to a single type, and just allowing full stack teams to work with confidence is the thing that we've worked towards. So this level of tooling requires our subgraphs to be able to test against a router instance that includes their own changes. It should be quick enough to run on every commit in a CD context and should be flexible enough to facilitate various testing tools utilized by different subgraphs. We don't have just one kind of subgraph at Shutterstock. We have DGS represented, Ariadne, Apollo Server, and TypeScript, JavaScript. We have deploys that are in the context of Kubernetes, serverless on AWS, and also local development to support.
Yeah, and at Shutterstock, we have 4 different types of environments. So we need to support code build, Jenkins, GitHub Action, and local development because we want our software engineers to be able to test their changes like the pipeline will do. So what we did is create a Python script that download all subgraphs, overwrite the subgraph change on the current repo, and then rebuild a supergraph deployed in ephemeral router. And we had to do a Python script because we need to support all those 4 environments. So for example, in Jenkins, we had to create a good old groovy plugins. So with 1 line of code here, deploy with ephemeral router, we enable engineers to deploy their changes alongside an ephemeral router with an ephemeral supergraph if you want. And here is the example for GitHub Action. So again, with just a reusable GitHub Action, engineers can directly deploy everything and run their changes. So let's take a quick look at how it works. You install your dependencies, you build your subgraph schema. Then after that, we download all the subgraphs with the Python script via introspection. We overwrite subgraphs. We build the supergraph. We then build a Docker image of the router by injecting that supergraph inside of it. After that, we deploy the ephemeral router. We then deploy alongside your subgraphs. When everything is deployed, you can run your acceptance tests against the FQDN. And then after that, if everything works, you can push to prods. So you see, all of those steps needs to work in order to deploy to prod. That can be a little bit tricky. So we have some problem with this solution. The first one is timeout. Because we are doing a loop of over 40 subgraphs and we are getting them via introspection, we saw that sometimes we have some timeout issue. The custom scripting in Python needs to be managed and maintained. And also it increases the time for the pipeline to run. And like I said, many steps needs to run one after another. So if one step fails, especially like on Jenkins, you need to restart the entire pipeline, which is painful. So, but good news is that you won't have to struggle like we did because the Rover team listened to our struggle and they released a new feature in Rover. So with a single command now, you can just call Rover supergraph compose. You pass in your graph reference and some overwrite in YAML file. And it will automatically download the supergraph and overwrite just the part of the schema that you wanted to overwrite. So that's really time-saving. So now the new pipeline looks like this. So you still install your dependencies and build your subgraph schema. But now you just need to call rover compose and build your supergraph. And then after that, you inject your supergraph inside your Docker image for your router. You deployed that ephemeral router. You then deploy your subgraphs. And then after that, you run your acceptance tests, and if everything works, then finally you can push to prods. So that really helped us save time on the pipeline, which is incredible. Thanks again for Rover team for implementing this. Really help save time.
Yeah, and through this improvement in pipeline time, we've provided a benefit that spans across our organization. Given 2 minutes saved per run due to this rover command, and our subgraphs averaging 25 runs per repository daily, and our growing number of subgraphs, we're at 41 as of yesterday, and a new one was deployed yesterday. We're talking over 1,000 pipeline runs per day, equating to weeks per year of pipeline runtime. And that's also developer waiting around time that we're saving. I mean, we all know what it means just to sit waiting for the pipeline to run. Okay, I guess I could get a coffee, but I have 3 minutes. So that's time that's saved, and that's time that we can deliver more quickly. So is this a solution that you should be leveraging? When a team's evaluating whether this layer of testing is needed, they should ask themselves if the scope that they need to test spans beyond a single subgraph. As you build out entity references in your supergraph, the need for this additional layer of validation may arise more frequently. That said, like many other CD tools, the earlier they're introduced in the project, the greater the return on investment. Additionally, for functionality that may not even use an entity reference, but may be running test cases that span across several subgraphs, that same layer of testing is going to be needed. We found that investing in this level of testing has allowed us to amplify the impact of our teams as they move to graph, and also improved our continual delivery practice at the same time. If any of you have come up with similar CD innovations through your graph journey, we would love to hear from you after the talk. So, in order to drive innovation with minimum friction, we found that breaking the monolith, empowering full-stack teams, and safely iterating shared entities are the things that we need to support our teams in doing. Allowing for tests to run on every commit is the way to support these goals, and doing so saves us thousands of hours of pipeline runtime, and devs waiting to see if their change is deployable. Quick feedback that a change is deliverable is the best way to incentivize small and frequent batches of work. And we found this really to be effective. In our AI image generation team, they're able to deploy small changes to, okay, I want to release a new drop-down filter. I want to release a new way of iterating on the model. And these can all be driven from the server, the way that we've done this, and they can be tested safely. Providing a prod-like test environment in the form of this ephemeral supergraph was the specific solution required to hold our subgraph teams to the standard of continual delivery. And by supporting this for all of our repo and pipeline types, we help all of our devs optimize, not just for deployment time, but also for the quality of their sleep. So thank you, and that's our presentation.